Today we're going to look at a few things that you've probably already seen before, isosceles and equilateral triangles, and we're going to look at how we prove right triangles congruent. A lot of the isosceles and the equilateral stuff you've probably already seen, some things you might already know. We're just going to kind of remind you of it. So we got a couple definitions here, the first one being legs of an isosceles triangle. We're going to say that those are two congruent sides of an isosceles triangle. So the legs are the ones that are congruent to each other, because if we recall, isosceles is two congruent sides. Next definition we have, the vertex angle is the vertex with the sides as the legs, or that are the legs. I'll say that are legs. So in this picture up here, that right there is my vertex angle. And then my last one is my base angles, and it's my two angles formed at the base of the congruent sides. So two angles formed at the base of congruent sides. Oops. So we got a little picture there, and it tells us angle 1 is my vertex angle, which we kind of pointed out before, and angle 2 and 3 are those base angles. Okay, we got a couple more theorems. Again, ones that you are probably at least a little familiar with. First one being isosceles triangle theorem, which says that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So basically, it's telling me here that AC is congruent to BC. What that tells me is the angle across from AC, which in this case is angle 2, is congruent to the angle across from the other one, which in this case is angle 1. So what that basically means is your base angles in your isosceles triangle are going to be equal. And we're going to use that in a couple different ways that you'll see coming up. The next one, kind of similar to what we were doing with parallel lines, we got a theorem, and then we have the theorem's converse, or what the kind of backwards statement of it. So it's telling me if I've got two angles of a triangle that are congruent, then the sides opposite those are also congruent. So here, if I've got these bottom two angles equal, I'm saying this side is congruent to this side. So basically, like I said, what we just said, but backwards. These examples, it says name two unmarked congruent angles, because they told me that C and D are congruent there. If C and D are congruent, then we are also going to say, I want us to take a look at angle, we're going to look at the other triangle. I have angle BCA, and I've got angle BAC. Sorry, my colors aren't working, so that's not very good. I'm going to say that those two are congruent. The reason being, I'm going to go back to my little theorem. I've got this side is equal to this side, So I want to look at the angles that are across from them. This angle is across there. And then this angle is across from the other side. So since those two sides are congruent, I'm going to say that the angles across from are congruent. Using that kind of same logic, this is going to use the converse theorem. Try number 2. Pause the video and see what you can do with that. And actually, now, why don't you try numbers 3 and 4 as well? Okay, it's kind of using the same ideas, using our isosceles theorem and our converse of that. So use those and see if you can figure out those two sets of congruent angles and congruent sides. And once you are back, let's move on to the back side. Okay, so here we got two, they're called corollaries. Don't really worry about that too much. They're kind of the same thing as a theorem or a postulate. We're not too worried about those words. Just know that it's something that the geometry gods have given us to help us find all this fun stuff. The first one is a triangle is equilateral if and only if it is equiangular. You might remember that word from our first day of doing triangles. We said that equiangular meant that all of our angles are equal. So, one of the ways that we can determine if a triangle is equilateral is knowing that all of the angles are equal. And our second corollary there kind of logically makes sense, because it tells us that each angle of an equilateral triangle measures 60 degrees. 180 degrees in a triangle, divide that by 3 angles, you're going to get 60 for each of them. And you'll also notice our more common definition that we've used to describe an equilateral triangle is all of its sides are congruent. So we got equal angles and equal sides. So in this case, if I look at these examples, number 5, it says, find the measure of angle R. So angle R is right here. And I don't want to just assume that that angle is equal to 60. But what I do want to do, a way that I could figure this out, I can use that isosceles triangle theorem that I just looked at. I know that these two sides are congruent to each other. This one's 5 and this one's 5. So I know that this angle is congruent to this angle. That I know from my isosceles triangle theorem. Okay, if I know that this angle here is 60, then I know between these two has to be 120 degrees. Because I took 180 degrees in a triangle, and I subtracted my 60 degrees that I know. That leaves me with 120, and then logically I have 2 angles left that are equal. I'm going to divide by 2, that gives me that 60. Again, I'm not assuming that 60 just because I see I got some equal sides and I have 160. That's the process that I want to go through. Similarly, now that I have all of these angles are 60 degrees, so now is when I can say that PR is also equal to 5 centimeters. Because my angle, I have angles that are congruent to each other across from sides that are also congruent to each other. So now I can say, okay, PR is equal to 5 centimeters. Try and do that with 7 and 8. Same idea, same logic. See what you can do. So pause the video for a second and do that. Once you come back, let's give number 9 a try. So number 9 says find the value of each variable, and it gives me all this crap. First thing I want to notice is I've got 2 sides that are equal to each other. let's do something with that first. Because if I've got two sides equal to each other and it's looking good to me because I've got the same variables on each of those, if those are equal, I'm just going to set them equal to each other and solve for y. So I'm going to add 5 to both sides, and I'm going to subtract 6y, so I'll get 8 equals 2y, y equals 4. Okay, easy enough. So I'm going to say, now I can say what each of these sides is equal to. This is equal to 32 minus 5 is 27. And this is equal to 24 plus 3 is also 27. Using one of those theorems that we just talked about, since these two sides are congruent, these two angles are congruent, and it actually told me that this one is congruent as well. Because if this angle is 4x minus 8, this one's 4x minus 8, and that one's also 4x minus 8. So in order to solve for x, I'm going to say, okay, 3 times 4x minus 8, or you could add them all together one at a time, equals 180. Because that's how many degrees are in a triangle again. Okay, so now I'm going to solve. 12x minus 24 equals 180. This is probably driving some of you crazy that I'm writing on top of this. I'm going to add 24 to both sides, so I'll get 204. And then I'm going to divide by 12 on both sides. So I get x equals 17. So y equals 4, and x equals 17 here. And again, that's all, we're using all this isosceles triangle, equilateral triangle, all that stuff. So why don't you, using that same logic, try and do number 10. So pause the video, do that, and then we'll come back. Okay. The last thing that I want to talk about very quickly, and the reason I'm doing it very quickly is because it's really similar to all the stuff that we've already looked at with proving right triangles congruent, or proving triangles congruent. And this one in particular talks about right triangles. One of the theorems that we have is if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and corresponding leg of another right triangle, then the triangles are congruent. So let's see, they gave me right triangle ABC. And that's my right triangle there. And they gave me right triangle PQR. They told me that AB is congruent to PQ. Actually, this picture isn't going to make sense, is it? Let's redo that. So they told, I'm going to say that, okay, AB is my hypotenuse here, PQ is my hypotenuse here. And then they told me that you know that those two are congruent, and then they're going to say, okay, BC is congruent to QR. Our theorem tells us that because I've got a hypotenuse equal to another hypotenuse and a leg equal to another leg, then I can say that these two triangles are congruent. So that's actually a little bit simpler than some of the other ones that we've been doing, because we only have two things to prove congruent. Or we only have to be given two things to prove congruent. But the stipulation with it is we have to be able to say that it's a right triangle. If they don't tell me it's a right triangle, I can't use this. So again, we'll do a little bit more practice with this stuff next class. So we can keep working on these proof skills that I know you love so much.